So here in this case, what happens that the decode unit, so as the processor would be having idea that that what is the source register 1 and source register 2, as well as that what is the instruction type and all that, right? Okay, so basically this particular design is for the R type. Okay, similarly R type means that the register type of instruction, the ALU instruction that we have. Okay, similarly for the memory type of instruction, right, we require somewhat some little bit modification for that, and for the branch also, that I will explain you later on. Okay, and yeah, obviously that once the processor, sorry, yeah, the control unit will get the idea that what operation I supposed to perform. In that case, what will happen that the processor control unit will provide the 4-bit signals over here, so appropriate ALU circuit would be activated in this case. Okay, so this is all about the decode unit. I'm moving to the next one. And for the load and store instruction, that how my decode unit will look like. So in the load unit, we know that or load instruction, we know that there is immediate value that we used to provide in the form of that offset. Okay, so we are having such kind of format like LDUR, that the destination register, let's say X1. Okay, and the address would be given like this, that consider that the base address is there in the X2 and the offset is, let's say, 4. Okay, so what will happen in this case, that this 4-bit value is only that 9-bit value. Okay, sorry, this value 4 is only 9-bit value. Okay, so what will happen that our ALU is able to perform operation over 64-bit data. So this 4-bit value supposed to be converted into 64-bit value. Okay, and that for that we require one specific hardware that is known as the sign extension hardware. In that case, what will happen that whatever value, smaller value is there, that would be expanded up to 64-bit value. So if you can recall my earlier lecture that we had discussed about the 0 extended expansion and the sign extended expansion. In the sign extension, if you can recall that we had discussed that if we are increasing the size of any bit value at that time, that we require to prepend some bit values. Okay, so which bit value would be prepended, that depends on the MSB value that we have. So suppose if the MSB is 1, it means that the value is negative. Okay, so if you want to preserve the sign at that time, all the prepended value should be 1. So then and then the sign would be extended, otherwise sign would never be extended if you will prepend the value with the 0. Okay, so that is the difference between the sign extended value and 0 extended value. In the case of 0 extended value, what will happen, that value would remain always positive. Okay, whereas in the case of sign extended value, the value would remain that whatever it is. Okay, and that sign would remain preserved. Okay, so this is the hardware, this particular hardware we require for the load and store instruction, as well as we require it for the add immediate instruction, if you can recall. Okay, the third one is that how to manage the branch. Okay, so also that if you can recall that the CBZ instruction, compare and branch, if the register is 0. Okay, register is having value 0 like this. Okay, so here the next value, let's say that the address, that where it required to go. Okay, let's say 30. Okay, so here that the X1 would be checked. If it is 0, okay, in that case that the program counter value should be updated to what, 30. Okay, means that the value, what current value of program counter is there, that would be incremented by 30. So in that case, what will happen, that in this case that register 1 would be read. Okay, what will happen, register 1 would be read. Okay, so that would be inputted over here. Okay, in the ALU, and ALU will perform the operation, or ALU will check that whether it is 0 or not. Okay, so obviously the simple way would be what, performing this operation is that rather than providing only x1 into one input, what will happen that x1 would be inputted. X1, yeah, x1 would be inputted over here, and here in this case what will happen, another register, that is the XZR register, if you can recall, that we have, okay, and the subtraction operation would be performed between these two. If the result is 0, it means that this particular variable, sorry, register is having value 0, okay, otherwise it is not having value 0, okay. And based on that result, this particular operation would be performed, okay. So here that it would be extended by the 64-bit value, okay, and here we are providing that this value is like the 30, 31, 32, okay. It is not exactly memory location, right? To our exact memory location would be at always offset of 4, okay, and that's why we require shift left 2 over here, and then this would be converted to the actual memory location. See, like here you can correlate it with the array. Like in array we provide the index is like 0, 1, 2, 3, 4, but actually in memory it is getting stored like 0, then 4, 8, like that. And that's why here then you can say that the every value is left shifted by 2 bits, okay, as we do with the array, okay. So it is similar like that. The next one is that here you can see it is the data path for the memory instruction and the R type of instruction, okay. So what happens that the instruction would come over here, okay, then the processor would decode that instruction. So based on, let's consider the R type of instruction. R type means the add, subtract kind of instruction. So what will happen that the register will get, sorry, the control unit will get the idea that which is the register 1, okay, and which is a register 2 from where I require to take the input, okay. Both would be inputted over here, okay, and yeah, it will be inputted to the ALU, okay. Now here you can see that we are having a multiplexer over here. Why do we need multiplexer? Suppose so see, the same hardware is going to be used for any kind of instruction, okay. So if the instruction is type of low memory instruction, in that case what will happen that it would be having only one register to read, okay, and another value would be the immediate value. So that immediate value, in the previous case we had taken the example of 30, that immediate value would go over here, okay, and that will be inputted over here, okay. Now here your control unit to specify, after getting that instruction type, the control unit will get idea that in this case for this instruction I require to take input from here, not from here, because this is the memory instruction. If this would have been add instruction, in that case that the control unit will take input from here, not from here, okay. And that's why we require multiplexer, and the signal of the multiplexer would be generated by the control unit, okay. So this is how the input would be passed to the ALU. Now once the input has been passed, okay, whatever result is there of the ALU, that should go to the destination register. Suppose if it is the add instruction, okay, so that would go to the destination register like this, okay.